Hi everyone, welcome to my YouTube channel. In this video, I'll be giving you a very basic overview of the citric acid cycle just so you could keep the big picture in your head. And I'll be telling you a mnemonic, a very popular mnemonic that you guys can use in order to make sure you don't forget the substrates in this cycle. Alright, let's get into it. What is the purpose of the citric acid cycle? Why do we need it? We need it so that we can generate electron donors. These will be our NADs and FADs, as I like to call them, NADH and FADH2, which are then going to go into the mitochondria and the electron transport chain and donate those electrons in order to finally allow for the production of ATP. And we know that ATP is very important, and it's basically what gives us energy and allows us to survive. So, in order to know the citric acid cycle, I want you guys to remember this simple sentence. Can I keep selling seashells for money, officer? Remember this one sentence. Can I keep selling seashells for money, officer? And that's going to tell you the substrates of the citric acid cycle. Ken is for citrate. I is for isocitrate. Keep, in the K is for ketoglutarate, but there's an alpha ketoglutarate. All right. Selling, the S is going to be for succinyl-CoA. And the seashells, there's another S that is going to be for succinate. The 4 is going to be for fumarate. The money, the M is going to be for malate. And the O in officer is going to be for oxaloacetate, or OAA. And of course it's a cycle. And we also need to know that in addition to OAA forming citrate, we need acetyl-CoA, which is going to be coming from pyruvate. Pyruvate will be converted into acetyl-CoA by an enzyme called pyruvate dehydrogenase. Actually, that's a whole complex. It's the pyruvate dehydrogenase complex, but this is all you need to know for our purposes. And we know that pyruvate came from glycolysis. So that's how we ended up here. We did glycolysis, we got pyruvate, we made that into acetyl-CoA, which can then be added to oxaloacetate to form citrate, isocitrate, alpha-ketoglutarate, succinyl-CoA, succinate, fumarate, malate, and the cycle continues. All right. So if you remember, I said that we were going to be generating FADH2 and NADH. Where are these going to be generated? All right, so this is one spot where it's going to be generated. NADH will be generated on this step, so we're basically converting NAD plus into NADH. That means we are reducing NAD plus into NaOH because, just a reminder, Leo the lion goes grr. Reduction is the gain of electrons, and by the NAD having a bond with the hydrogen, there's electrons there. So we gained electrons. The way I like to remember this is that our following substrate from isocitrate is alpha ketoglutarate. I just like to think of like an alpha male who's extra special. So he's extra special, so he's going to be one of the steps producing NADH. And the enzyme that's going to be catalyzing this step is called isocitrate dehydrogenase, which is easy to remember because it is named after the previous substrate. So isocitrate dehydrogenase. And the word dehydrogenase also makes sense because we are giving a hydrogen to NAD plus in order to form NADH. All right, now we're going to go from alpha ketoglutarate to succinyl-CoA. And this is going to be catalyzed by alpha-ketoglutarate dehydrogenase. All right, that's going to go to alpha-ketoglutarate dehydrogenase. That's the enzyme which will convert it into succinyl-CoA. Succinyl-CoA to succinate, since we're making succinate, it's going to be succinate. It's going to be succinyl-CoA synthetase. Synthetase. So we're kind of cleaving off this CoA and we're left with succinate. Now, in order to go from succinate to fumarate, we're going to have something called succinate dehydrogenase. All right, now this is another special step over here, because over here, we're going to be producing FADH2. The way I remember it is there's an F in fumarate, so the step in which we are getting fumarate, we're also getting FADH2, which also has an F. All right, and now we're going from fumarate to malate. So we're breaking down fumarate. So the enzyme that's going to do that is called fumarase. See how for the most part these enzymes are pretty much named based off of what they're doing, right? All right, so now we're left with malate. We're going to go from malate to oxaloacetate through something called malate dehydrogenase. There's that word again, dehydrogenase. So we are going to be having one of those special steps again where we're producing NADH from NAD+. We're giving NAD+ a hydrogen, which is forming NADH. And then to go from oxaloacetate to citrate, it's called citrate synthase. We're synthesizing citrate from oxaloacetate and acetyl-CoA, so it's going to be called citrate synthase. All right, now we are missing one more place where an electron donor will be generated, and that's over here. Remember how I said I remember that the alpha is special, so he's producing an NADH, or the conversion of isocitrate to alpha-ketoglutarate is producing NADH. Well, he is so special that he is producing another NADH when he is being converted to succinyl-CoA from alpha-ketoglutarate. And again, there's that word, dehydrogenase, so we are taking a hydrogen, adding it to NAD+, in order to form NADH. There's only one more special step that we are missing, and that's going to be over here. That's going to be over here. And I like to remember this step because it's pretty much at the bottom of the cycle, the way that we draw it, because succinate is at the bottom, citrate is at the top. I just like to remember that the bottom one is also a special step. In this step, we're going to be generating GTP, which is another form of energy. So we're going to be generating GTP from GDP. Okay, so let's go over all of this one more time to make sure you understood. Okay, we went through glycolysis. We started off with glucose, we ended off with pyruvate. We also produced some energy in the process. Then we are being converted into acetyl-CoA from pyruvate dehydrogenase because pyruvate is going to allow for the occurrence of the citric acid cycle. All right, now we have acetyl-CoA. Acetyl-CoA is going to combine with oxaloacetate to form citrate. Citrate is going to form into isocitrate. This is not a very special step, but just so you know, the enzyme involved here is aconase, or however you pronounce that. So we're going to go from citrate to isocitrate. We're going to go from isocitrate to alpha-ketoglutarate, and this is a special step because we are producing NADH in the process. Then we are going to go from alpha-ketoglutarate to succinyl-CoA, another special step because because alpha is special. That's just how I like to remember it. So we're producing another NADH. Then we're going to go from succinyl-CoA to succinate, and we're going to be using succinyl-CoA synthetase as our enzyme in order to cleave off that acetyl-CoA group. And we are also, not acetyl-CoA, sorry, just the coenzyme A group. And then we're going to be producing GTP in that process as well. Then to go from succinate to fumarate, we're going to be using succinate dehydrogenase. Another special step, but this time instead of NADH, we're making FADH2, and the way remember that is that we're making fumarate, which starts with an F, and we're also making FADH2, which also starts with an F. All right, and then we're going to go to malate with fumarase, which means that fumarate is being broken down. And then we're going to go from malate to oxaloacetate, another dehydrogenase enzyme. So this is another special step in which we're producing NADH, and the cycle continues. The cycle is going to keep on going like that forever. These electron donors, just to reiterate, these electron donors that have been generated, your NADs and FADs, these are going to go into the mitochondria where the electron transport chain is happening. And if you guys want, I can make a separate video in the future detailing the electron transport chain. Alright, thanks for watching. I hope that was helpful. Let me know if you have any questions, concerns, or advice for me and my videos in the comments. Thank you.